So if you navigate your way over to the Sage module on Cholesky factorizations, you'll find two calculators, which I hope you think are useful. So the important thing with Cholesky is actually the LD-L transpose factorization. And so remember, to do this, what you end up doing is you apply PS equals LU, and you terminate if you ever need a row swap, which means you won't have LD-L transpose, but you can still conclude that you're indefinite in that situation. And then if you can factor S as LU, so if you don't need a row swap, then you can factor S as LD-L transpose, where L came from LU, and D was the diagonal matrix whose diagonal entries were the pivots in U. So in this first calculator here, I've written some code that should produce an LD-L transpose factorization if that factorization exists. So I've predefined a matrix S, so put your favorite real symmetric matrix S in place of mine here. And if you click evaluate, you'll see that I have this predefined real symmetric matrix S, and then I factored S as LD-L transpose, where L is this lower unitriangular matrix, and D is this real diagonal matrix. One interesting thing about this one is that it looks like my entries in D are 7, -2, 5, and 1. So I have a mixture of plus and positive and negative diagonal entries in D, which means this S was indefinite. So that's a more efficient way to establish the definiteness of S, because I didn't have to calculate any eigenvalues. And then finally, we can use LD-L transpose to factor or to produce a Cholesky factorization, which expresses any positive semi-definite matrix S as the Gramian of R, where R is an upper triangular matrix with non-negative diagonal. Remember, in this situation, R equals root D times L transpose. So if I've predefined a matrix S here, but you should feel free to replace S with your favorite real symmetric matrix, and click evaluate. And if I scroll down to my result, I see that this matrix S, it is real symmetric, and it does have an R here. So this does factor as R transpose times R. And this R is upper triangular with a non-negative diagonal. And so this S, it is positive semi-definite because it has a Cholesky factorization. So hopefully you find these two calculators useful. You should definitely use them to check your work if you're doing any calculations.